So now we've got a comparison question. Let's say that you have two options for investing. That means you're going to put money in with the hope and expectation that you're going to get more money out at the end. So you have two options to invest, and you got to figure out, well, which one of the two options should you choose, and then explain why. Okay, and again, do it. Figuring out the math will be the easiest thing to do. So let's say you have $2,000 that you can invest for 5 years. You try to figure out right now the future value that you're going to have. So you're going to invest $2,000 in principal for 5 years at 8% interest. That's 0.08 as a decimal, and it's compounded quarterly, so that's 4. So I'm going to do 0.08 divided by 4. It's going to give me 0.02. And if it's in there for 5 years, and it's compounded 4 times per year, that means it's compounded for a total of 20 times. And I got to figure out, well, how much money do I have at the end? Because this is a future value problem, I want to use the formula for future value. Again, this is my future value formula. So A is equal to P times 1 plus I to the exponent n. So my P value, my present value, my principal is $2,000. 1.0, not 002, just 1.02, and then my n value is going to be 20. So my final amount, if I take option A, is going to be 1.02 to the exponent 20 times 2,000. It's going to give me 2971, approximately, let's call it 89. Okay, so if under these conditions, I would get, I would end off with $2,971 and change. Okay, but if I went to a different bank and they gave me this option, I want to figure how much this is going to be. So again, I've got the same $2,000 that I can invest in principal. Okay, I'm still trying to figure out my final value. Also, I'm going to invest for 5 years, except this time they're giving me 6.9%, which is 0.069 as a decimal. And this one's compounded monthly. So in this case, compounded 12 times per year. So I want to figure out, well, what is that actually worth? So 0.069 divided by 12, so 0.069 divided by 12 is going to give me 0.00575. Okay, and then because it's in there for 5 years, I multiply that by the number of compounding periods per year, and each year it's compounded 12 times for a grand total of 60 compounding periods. Same formula, just different numbers to plug in. So in this case, A is going to equal 2,000 times 1.00575 to the exponent 60. So now I'm going to do the math real quick. 1.00575 to the exponent 60 times 2,000 is going to give me 2821.19. Okay, so if I compare those two options, I can see that I'm going to get more money out of option A you get more money. Okay, so if I'm investing, I would choose option A because I'm going to get more money because I'm putting money in and I'm expecting to get this money out. However, if I look at question C here, if I was given the same two options for a loan, that means I'm borrowing money instead of investing the money. Remember, when you borrow money, you have to pay it back. Okay, would I still make the same choice? Would I still choose option A? Well, if I borrowed money and had to pay money back, we can see here that option A is a little more than $150 more expensive. So I would actually want to choose option B for a loan. Okay. Because if I was borrowing this money, then if I went with option B, I would actually save myself about $150. Okay. So between the two options, I would choose option B. Option B because, oh, oops, option B because it's cheaper than option A if I'm borrowing money. Okay. So depending on the context, compound interest can either be your friend or it can be potentially your enemy. And we'll get into that a little more when we're looking further at personal finance. Okay, so particularly when you're borrowing money for a major purchase like buying a car or you're looking to buy a house, you got to weigh out your compounding options in terms of the interest rate, in terms of the length of time it's invested in terms of years, and the number of compounding periods per year. Okay, so if you want to have the cheapest possible mortgage, you want to have a low interest rate with very few compounding options for a short amount of time, if at all possible.